All right, our last presenter today is David Jin. He is the AI Test Tools lead at the Chief Digital and AI Office. Within this role, he leads the Joint AI Test Infrastructure Capability Program, which is developing software tools for rigorous AI algorithmic testing. His background is in computer vision and pure mathematics. They should be pulled up in
somewhere
right now.
Okay, excellent. I have until 12:20, is it? 27? Okay. I'll try to go till 12:20. I think 12:20 is lunch.
Yes.
And then so if people want to ask questions and sacrifice their lunch, you're welcome to. I'll stay afterwards. Slides are here. Okay. Great. Yeah, and then feel free to ask questions as well during it. We'll try to save some of them to the end, but if there's anything that is like inhibiting understanding, then feel free to ask. Can you hear me properly? I don't know if I'm going through the mic. Yeah, great. Okay, fantastic. Okay, so hello, my name is David Jin. I'm the test tools lead at the CDAO. I think we've seen a few projects today that were sponsored by the CDAO, but in case you don't know what the CDAO is the Chief Digital and AI Office within OSD. It recently, very recent organization in the last 2 years, came about unifying a bunch of existing DoD organizations, including the JATIC, the Chief Data Officer at VANA, and the Defense Digital Service, with the goal of unifying and setting a foundation for the department's digital, AI, data, and analytics strategy. And so this work is a part of that, a small part of that, within the realm of test and evaluation. This is a program of record that recently started in FY23, running for the next 5 years until FY28, called the Joint AI Test Infrastructure Capability, or the JATIC program. Builds on a lot of the work that you heard Brian talk about, that you heard John talk about as well, in terms of the need for tools for AI, and so this program is trying to do some of that. Awesome, that works. Okay. So first I'll get into some of the impetus for why this program exists and some of the things that caused it. Sorry, I can't see the slides, and oh, I can now. Okay, great. But I'll try to go as I read them. The first one was from the RAI Strategy and Implementation Pathway, the Responsible AI Strategy and Implementation Pathway, which was signed by the DepSecDef, Kath Hicks, in June 22. It was a follow-up to the DoD's implementation of the 5 ethical principles for AI, and a document that really tried to detail how to actually operationalize these principles. The LOE 2 within that document, it's publicly available if you want to view it, was totally about test and evaluation, and in particular LOE 2.1.2 and 2.1.3 were some of the charges that were given to the CDAO, T&E, to develop these test tools. And so 2.1.2 charges CDAO, T&E to develop or acquire AI-related T&E tools to use the resource for AI developers and testers, drawing upon best practices and innovative research of industry and the academic community, as well as commercial medical technology when appropriate. And 2.1.3 asks to create a central repository of these tools for T&E of AI to enable easy and continuous testing for DoD testers. Furthermore, Brian talked about this earlier, the NATIC study. And so this was a study done for the DepSecDef and CAPE to give data-driven decisions about AI T&E. And essentially, I'm pulling like one quote from a whole interim study, but one of the quotes that said was that there was widespread interest across the DoD enterprise for T&E infrastructure to address novel and exacerbated challenges posed by T&E of AI. And then while programs are currently investing locally in T&E resources, there's a consistent desire across survey programs for DoD enterprise support. And so another way that you may be able to read that, reading between the lines a little bit, is that there has been a lot of investment across the DoD in AI T&E capabilities, but none of these things have really had the interoperability, the effectiveness, or the reach to scale across the DoD, become an enterprise level capability. And so that's what this program is trying to do. So, okay. Okay, so the next thing is about what we're actually doing within this first year. So again, JATIC started in FY23, so we've been doing a lot of planning, and we're sort of just starting off. So the rest of the slides are sort of our vision, some of our design principles, and what we're trying to initially do within our MVP. And so first of all, JATIC is developing an interoperable set of state-of-the-art software for rigorous AI model and algorithm T&E. That's what we set to be our initial focus. So the way CDAO breaks down AI test and evaluation is in this sort of this pie chart right here. There's these 4 different quadrants, starting from AI model T&E. So starting with the AI model itself, the most isolated component, moving into systems integration, so that AI model integrated into other software, other hardware, legacy software, other AI models itself, potentially. And then moving on to human-machine T&E, so an AI algorithm in that system, really considering the human-machine team, the human-machine interface, and then finally operational T&E within an operationally realistic environment. And so we're focusing on the model level T&E first. The reason we're doing that sort of gets back to the charge of the program to develop things that can be scaled across the enterprise, really enterprise-wide capabilities. And from our perspective, the program offices, the services are the best best position to develop things at a deeper systems level or operational level, and they know their missions best to develop things at that more integrated level. But on a model level, there's a lot of commonalities between models that we see across different use cases. For instance, computer vision models, transformer models, these architectures are very similar very often across a lot of different diverse mission use cases. And so we see an opportunity to build those things that can be made, hopefully, effective across the enterprise. So 2 of the things I think I mentioned, JATIC is designed to support wide integration across DoD environments and mission use cases. And a new thing, what we're focusing on within our MVP is computer vision object detection and classification. The reason we're focusing on these sort of tasks is there's sort of a confluence of an AI task that is relatively mature. There's a lot of research in CV object detection and classification within the literature. There's a lot of sort of open source and academic work as well. And there are also use cases that have a lot of actual applications in the DoD. There are others as well, obviously, but a lot of the mission and areas where we've been seeing a lot of development have been these use cases, including things like medical imaging, ATR, ISR, UAVs or UEVs, and different things like this, autonomous vehicles. They all sort of use computer vision at some point within their life cycle, within their system as well. Okay, and some of the areas that we're developing capability in within JATIC, there's a bunch of them, but some of the areas that we're developing capability and functionality within this smaller quadrant of AI model T&E include things like model performance, reliability, throughput testing, confidence calibration, trustworthiness, explainable and interpretable AI, data perturbations, transformations, adversarial attacks and defenses, and how robust a model is to different transformations, perturbations, attacks and defenses, dataset sampling, distribution and bias analysis, label analysis and assistance, so understanding if your ground truth has any errors, and also T&E standard reporting formats and generation tools. So a bunch of stuff we're building, all of it, still falls within those larger constraining elements of computer vision, classification, object detection, and mostly fall within the model T&E quadrant as well. Okay, I'll pause here. There's a bunch of stuff on this slide. This is like a main summary slide. If there's any questions. Okay, sounds good. So the rest of these slides sort of get into some of the design principles that we're sort of taking, and the way in which we're trying to build T&E tools such that they will be more successful, at least, at being able to be leveraged across the enterprise and keeping up with the speed of AI model development than some of the tools that have been previously built, both within the JATIC, Project Maven, and other AI projects across the DoD. And so the first principle that we're really trying to embrace is this idea of continuous machine learning, or Mlops. And so the tagline here is, to be effective, AI T&E capabilities must integrate seamlessly within Mlops pipelines. And so, continuous testing of AI requires this close integration to these pipelines, and this is especially important as AI models are trained more frequently. And when we do see this integration, there's a whole bunch of stuff here, but basically, we see that there's a huge amount of synergy between test and evaluation as you're able to do it successfully. And so it's a very close analog to the story of DevOps, but some of the things that uniquely in AI you're able to do better when you are integrated are, if you're able to integrate your test and evaluation with workflow orchestration, you get automated execution of model test plans. And so, for instance, perhaps, after your model is retrained with new data, you get automatic kicking off of T&E, so you can validate that you're still meeting those requirements. Next one, if your T&E is integrated model registries experiment tracking, you have improved T&E traceability. So all of the across every single data set, across every single model that you've ever tested, you have that traceability, and you have that easy comparison. The visualization dashboards integration also sort of allows that seamless comparison. Integrating T&E with hyperparameter optimization helps, gives you the ability to optimize your hyperparameters across these different tests you're doing, including robustness, explainability, etc. And then integrating T&E with your labeling pipeline as well allows you to use your model inference results to inform potential errors in your ground truth labels. And so if you have a model that's deployed in operations, you have that consistently collecting data. And then those predictions, for instance, tell you that are very, very confident that there is something there and your ground truth is labeled, that there's not something there, that you might want to revisit that ground truth to look at that. But it's only really enabled if you're able to get that integration. There's a huge amount of more things that you can get here, but the essential tagline is that our T&E capabilities really need to be deeply integrated, at least at the model level, to take advantage of all these things. And all these MLOps capabilities are things that exist in industry. There have been tools that have been sort of built for these purposes, but the habit of rebuilding and building bespoke T&E tools is really going to hold the DoD back if it really wants to accelerate and have this close feedback loop. I'll pause quickly. Okay. All right, so integration good, also integration hard. So integration is extremely good, it's also extremely challenging. There's a bunch of reasons why it's challenging in general, but we identified 3 primary integration challenges I'm going to talk about. The first one is integrating our tools into these development or testing environments. This is hard in general, but it's really hard, especially in the DoD. It's very hard to integrate things in classified and sensitive environments. A lot of times in the DoD, one problem that we ran into is that data lives where it does, and usually that's where AI needs to be tested, also developed and created, because it's very, very difficult to move a lot of data. There's a lot of questions about data ownership. There's a lot of questions about the security and classification, etc. And so getting tools to integrate into those environments is extremely critical. The next thing is actually integrating into these ML platforms, MLOps pipelines, and other ML tools. This is really, really difficult. There's been a huge explosion of these tools in the last 10 years. And so it's very difficult to sort of know what to use, what the standards are, and various things like this. As well, this explosion is sort of is mirrored perhaps on the DoD side, where many different DoD organizations, as Brian mentioned, many different program offices are starting to do AI, but they're not coordinated. They haven't chose the same sort of stack. They haven't chose the same tools they're using. Perhaps they're using the best of breed tools for their given bespoke problems, but that doesn't result in a standardized solution across the DoD. And integrating into each one of those is very, very difficult. And so we're trying to solve some of that problem. Okay, and the last one is integration with AI model and data formats. A lot of talk about this earlier in the keynote. Sometimes they're black boxes. Sometimes we have very restricted access to them. Partially contract and acquisitions problem, partially a lack of standards just to provide to vendors such that they can actually do that and build to the formats that we're looking for. Okay, so a bunch of different challenges. These are some of the big ones. So we're trying to address these things with a few different design decisions. One of the biggest ones that we decided after a lot of reflection is to design our tools as Python libraries to allow for this easy deployment and wide integration. We see a few different benefits for this. I'll run through these really quickly. But the first is straightforward deployment, setup, and use within these development testing environments. We've generally found it's very, very hard to deploy Docker containers. It's very, very hard to deploy executable software into a lot of environments. There's a lot of processes you need to go through to actually secure the runtime of runtime of these containers. But deploying software relatively static, deploying Python libraries that are more static, oftentimes not even compiled, has been okay. And so that's been a form factor that's allowed us to try to sort of get around that problem of difficulty of deployments. The next thing here is seamless integration with key MLOps platforms and capabilities. We have Databricks, SageMaker, MLflow, weights and biases, some of these things that we've seen used across the DoD on the right-hand side here. And one commonality between them is that it's very easy to integrate Python libraries with them. That Python in general is the mechanism by which you get things to work. And so we've decided to go with that. This has been sort of a different decision than a lot of tools previously we've seen developed in the DoD have used. That and choosing to sort of develop your own software package, choosing to develop your own container or microservice architecture sort of solution really makes that integration into these platforms very, very difficult. So that's one lesson that we've learned. And then finally, to sort of solve the problem of, or try an approach to solve the problem of standardized model formats, we've developed some standardized formats within JATIC for model, data, metrics, and transformation types, which are widely compatible, easy to satisfy, informative, and dependency-free. They are based off of the formats in some logos in the bottom right that are PyTorch, Hugging Face, TensorFlow. Our formats are compatible with those. They're mostly specifications of most of those things. So they're a little more picky, so you can know what to expect in each one of them. If you want to know more, happy to chat more about that later. Okay, now there's another picture. Yeah, so this is a picture of the integration of tools into weights and biases. You can see, how this would be useful for a teeny engineer. You have like a bunch of models here on the right-hand side. You have a bunch of ways which you can compare all of your data and all the parameters between those models, and it really sort of gives you a visualization capability that would be very, very hard to develop in the DoD. But if you can take advantage of it, if you can set up that integration, you have something very, very strong, very synergistic. Okay, this is a very quick summary. I won't go through all of these, of some of the existing capabilities previously funded by the DoD that we're continuing to fund and trying to mature and transition. I guess the overall story of this is these capabilities sort of vary across a very large range of AI T&E functionalities, and there has been a lot of work done in the DoD, and our task, as we see it, is really to try to harness some of that work and try to mature it, productize it, make it in a form factor that is both distributable and integrated, and also increase the documentation, the tutorials on these things so they can be very widely used by those who might not have AI T&E background, or AI background, probably more correctly. A star here, this is also another interesting thing, indicates something that's open source. We're trying to use open source as much as possible. It's really hard to distribute things otherwise, if at least we found, if that's not the case. Okay, I have 5 minutes. So AI T&E platform. Okay, so in addition to creating all these libraries, we're also developing one other sort of capability within our program, which is an AI T&E platform. It's a comprehensive platform composed of open source libraries that's tailored for AI ML testing. And so roughly the idea here is that Python libraries are really good for you if you've already adopted an enterprise platform, something that pulls together all of those things, that gives you that dashboard, gives you that sort of workflow automation, gives you that tracking. But if you haven't, a bunch of libraries are a little bit difficult to sort of get spun up and using. And there's sort of a high learning curve to using things in Python. And so for those without the infrastructure, one of the goals of JATIC within this platform is to provide the best of breed open source tools to jumpstart AI T&E from day one, to both make this platform something that's seamlessly orchestrated and tailored for AI T&E and very quickly deployable both to commercial clouds, on-prem, local machines, and also HPCs using infrastructure as code. So some of the logos in the bottom, we want to be deployable to AWS, Azure, and you can use it hopefully using Kubernetes or also just Docker. Okay, and then some of the things that we want to provide capabilities for, these were sort of listed earlier, but some of the standard MLOps things, so workflow orchestration, model registry, experiment tracking, a database and object store, visualization dashboards, JupyterLab IDEs, and multi-GPU resource management. When we think of this product, I think of both myself and then also a lot of other colleagues in CDAO T&E who were previously doing test and evaluation on actual AI programs, and it was very, very haphazard. We would have Jupyter notebooks where you'd have your code and you have to run the cells in a certain order or things wouldn't work, and you would have like files in your computer on some drive that's the data, and there'd be like one update to the data, and it would be an amendment, and you'd name things in crazy ways. And so the general idea here is that we want to bring some sort of maturity to that process of AI T&E, even in cases where maybe there's just one test engineer. There's sort of always these really constrained budgets for T&E, and we're trying to bring to bear a lot of the things that exist in open source and lower the barrier for that. We think a lot of really good capabilities exist if only they can be leveraged, if only they can be made accessible, made secure so that they can be deployed to our environments, that we bring a lot of benefit from that. Okay, there's a bunch more slides in this. These slides I think are on the DataWorks website, and so if you guys want, you can go through them in detail. There's just some more about some of the stuff we're trying to do, but probably for the sake of time, I think that I'll just stop for questions, and then I think my email is also on the thing, so feel free to reach out. We would really love, we're looking for a lot of collaboration. As mentioned, we're trying to make these tools that we've built very widely accessible and applicable to a lot of your mission use cases and mission use cases across the DoD. So if you're interested in using these, if you're interested in providing feedback as to some things, test capabilities that you guys would like and you'd like to see, or the limitations you currently have, please do reach out. That's what we're funded to do, to sort of enable those projects. So yeah, please reach out. We would really love to collaborate. Okay, that's all. I'll open it for questions.
Hi, nice presentation, very comprehensive, good outline, some depth. I just wonder if you could expand a little more on the attacks and defenses with regard to cyber across platforms, nipper, sipper.
Yeah, I don't think that we have anything that we're developing for cyber attacks currently within our program. Most of the adversarial attacks within our tools build on ART, which is Adversarial Robustness Toolbox, or Armory, some work previously done under DARPA Guard. And that work is really constrained to the types of attacks, adversarial attacks, that are sort of unique vectors that machine learning opens up. And so those are either evasion attacks, poisoning attacks, inversion attacks, and things like that. And essentially those are attacks that, if you know an adversary, if you know that there's a machine learning model there, an adversary can sort of fool that machine learning model, or get information out of the machine learning model, or influence the way in which that machine learning model will interact with some sort of thing. And so that's really been our focus there. But if there's particular things that are at the intersection of AI and cyber that you're interested in, really interested to chat and see if we can develop anything there.
Hi, thanks for the talk. I'm a little sad that you stopped at the deep dive as to current capabilities, because I'm from a national lab, a DOE lab, and I'm interested in partnering and taking advantage of the platform. So can you just speak a little bit to what's accessible to me as a scientist at a national lab right now?
Yeah, I don't have the slides anymore. Okay. Okay. Let me go back. So I think this table is the. Sorry, this pressing button is really slow. It's even before this one. Sorry. Okay. So I think this is the best summary. If you would like to sort of read some of the capabilities that are on the right-hand side, I think that gives a very brief description of the things that we're working on, or that these tools do. And if you want to learn more, a lot of them are open source. You can just look them up, or you can reach out, and we'll try to make them available to you.
Any other questions? Or is everyone ready for lunch? All right, well, let's thank all three of our speakers one more time.